record on this computer. I am recording. So they got that weird voice probably at the start of that when you start the video. There you go. That's a little Easter egg just for you. Where are we going? Where have we been? So where have we been? 2A, 2B. 2B or not to be. We definitely did 2B. And those were over our unit analysis. So I'm pretty sure I said it, but like I don't expect you to remember conversions. Like I will give you all the charts that you need, those sorts of numbers. I don't expect numbers to be memorized for the most part. If there's something that's got to be memorized, it's something that we're using over and over again or something, you know. It's not going to be like conversion stuff, you know. But that was 2A, 2B. So are there any questions over the work that you've done so far? I guess is the first thing. If you have any questions over unit analysis, that would be that. This would be the time. But if not, I think we will go on to section 3A. So 3A is about percentages. We're going to talk about uses and abuses of percentages. 3B is a section about putting numbers into perspective. So we're going to talk about different sorts of scales of things. I think that's the one where we convert a year to seconds or something like that. Sorry, I said that weird. That's the one where we convert 1 billion seconds to how many years that is, something like that. Turns out 1 billion is really, really large. But we are in 3A, so hopefully you watch the video. It is going to be about, obviously, percentages. So I think we've done percentages of before and talked about how to do that. But this says find the absolute change and find the relative change. So absolute change, there's basically two different ways that we tell growth or decay, right? Or going up or going down. One way is the straightforward way. So this is the way that we talk about the difference from that one number to the other number. And something to note is that this says, where are we at? We went from 8.7 million in 2005 to 16.1 million in 2015. You might want to note if you're doing anything with these numbers, or like if you're subtracting these numbers or something like that, you know, you might want to put the word million there. What is that? I don't want to carry that in my head. Okay. I'm not as particular probably with the units on this section as I was probably on the previous one. Okay, so if you watch the video and you know what the absolute change or the absolute difference between two things is, like this should seriously take you like 10 seconds to do. And I've kind of hinted at what to do. Okay, so the first thing we're finding is absolute change. The second thing that we're finding is relative change. So these were the two sorts of changes we talked about. Well, I'll wait till I do the next one and I'll explain it all throughout. I think maybe it'd be better at that point. Okay, so I should have enough time to do this one. If you know what it is, then you should be able to get it pretty quickly, hopefully. If not, then hopefully we're going to do a few of these. So maybe you'll get the next one. I don't know what to say. All right, so the absolute difference is absolutely the difference between the two. It's going to be the 7.4 million. What'd y'all say? 25. I don't know where that's coming from. Okay.
That would be percentage of change.
Okay, yeah. Okay, yeah. So that's, I think the next question is what that one is, right? Maybe I'm giving away too much. But the absolute change is just one minus the other. It is how much it grows or how much it decays or goes down, right? Or how much you've lost, I guess I should say, right? How much it grows or how much there's loss. So we subtract the two numbers, we're going to get 7.4. We have to account for the fact they are in millions to talk about a difference of 7.4. This next one, after you know this next one, you know how to do absolute and relative for anything. If they ask you for absolute, if they ask you for relative, this one is relative change. So if we're looking at these two numbers, I'll give you a hint. You can use the solution from your previous one maybe. But this should be in a percentage. So we have to find out how much this thing grew relatively. So how much did this grow relatively? And I'm talking about relative to what? Relative to what it's starting out at. And so I think just going with this one, going 2 decimal places, I should round up. Be careful on that one. And it should have a percent sign, I think. Although I think I might have put it in without a percent sign as well. I wasn't quite as picky on the units on some of these. Some of them I am, but there's a reason why I am, and we'll go over that. But let's see. I'm a little more relaxed with the units on this. Let's just say that. Round it to the nearest 2 decimal places. So I believe it should be rounded up. Should get like a 0.06, hopefully. All right, so I'll give you all a few seconds on this. But after you've done that first part, it should take you like 1 more second to get like that. It's like 1 more step. 2 more steps because you got to convert it to a percentage maybe. But all right. That sound weirds me out. It sounds like it's wrong. It did kind of wrong. Okay. 85.06. What do y'all say? 85 if you just rounded it. Okay. It's not. Oh, be careful with this. So I know that first one was in millions, but that's because we're subtracting millions from millions. When we also divide by millions, it does kind of a weird thing. We're not in millions anymore. We're in percentages. We're comparing one number to another number. Those two numbers are in millions, but this number should be a percentage. 85.05 is good enough. 85. It looks like y'all are hitting like all around the ballpark for the most part, just like sort of rounding stuff. So find the relative change. Okay, so if you remember new minus old over old, or I think the other one is compared minus reference. Is that what they call it? Over reference. I believe that's the other verbiage the book uses. But if you just like remember new minus old over old. So new minus old over old works if we have basically time stuff. We're going from 2015 to 2005 to 2015. So we have a sort of time comparison. If we don't have a time comparison, that's when they're using the compared versus the reference. Same concept, just like different sort of verbiage. But it's the same concept. You're subtracting two numbers, you're taking their difference, and you're comparing it to where you started or to what your reference is. So they have to kind of specify what your reference is sometimes. But yeah, so this, when we divide the two numbers, we should be getting something like 0.85. You can round that to 0.85.06. Questions about this? So absolute and relative change, it can go up, and I've kind of hinted at it, and I think it does it in this one, but it can also go the other way, right? And so I think this is decreased from this to this. So you do have to put these things in the correct order. It's got to be new minus old, and then we do new minus old over old, right? So it is important to put signs in there, I guess is what I'm trying to hit.
This one should be a whole number, right?
I think you can do it to one decimal place. I think it's just going to be one decimal place. It's probably the easiest.
Instead of a percentage.
Yeah, this should not be a percentage. We're not dividing things. This is the absolute. This is the absolute's the straightforward one. It's like, what is the difference between these things? What is the change? Ugh. Okay, and I kind of hinted at it, but you want to do new minus old. So it is kind of important to what order you, or it is very important, not kind of. It is very important to like what order you do these subtractions in, right? So we're going to take this one minus that one. And if we do that, what does that mean about our number? If we subtract the small one from the big one, or the big one from the small one, we get negative numbers. So you should have put a negative sign in front of there. If you told me it went down or something, minus 12.4 pounds LB, minus 12.4. This is not in millions, it's just in pounds. So the previous problem said millions. I know why you said millions, because the previous problem said millions, but this one just says pounds. It's just in whole pounds, or fractional pounds, I guess. But all right, so now we want to do relative change, same problem. So if the absolute change is negative, guess what that means about? If the absolute change is negative and the absolute change is going over, I think that might mean I'm supposed to round it to two decimal places. Okay. And this one should have a percent on it. This one is in percents. And I think I did put percents on my solution. I think it might count it wrong if you don't have it. It counted me wrong. The important thing is that you give these things a try. Like I'm not like, I'm not using this program to grade anything. I'm using it just so we can be more interactive a little bit. Okay, what did we get? Minus 12.4 from the previous one. Is that what it was? So if we do new minus old, over old. So this one was my new one. This one is my old one. So what that tells me, if I'm doing new minus old, my old one has to be this one. And if that's my old one, that's the one I'm dividing by. So hopefully you divided by that one. And if you divided by that one, you should get something like a negative 18%. So this one should also be negative. We're putting a negative over a positive. Overall, it's going to come out negative as well. What did we say?
I was right, but I forgot the percent sign.
Oh, okay, that's fine. Like y'all are, as long as you're getting it, as long as you realize it's percent, put a comma there. Oh man, yeah, so close. All right, so a lot of people look like they're getting it. They rounded it or something. That's fine. Okay. Okay. The life expectancy at birth of American women is 81.2 years, is blank percent greater than the life expectancy of men, which is 76.4. So I will tell you this. This isn't super obvious which one they're referencing, maybe at first. It might take a little time to figure that thing out. It's like, which one is the reference? Which one's the new? Which one's the old one, right? So I'll give you a hint. It's like this word really kind of tells you if you're going greater, this should be going up. It should be positive. So that should tell you which direction to subtract the two numbers in. And if that tells you which direction to subtract the two numbers in, it should also tell you which one to divide them by. And two decimal places. I think these were the ones I wasn't, you don't have to put percent sign on there because it says it in the problem. I think these were the ones I don't really care if you put percent. If you did, it would be redundant technically, but. And so I guess the other thing is they're asking for a percent. So we kind of went over this in the previous one, but percent changes are relative changes. So I hope that wasn't the point of confusion. But yeah, percent changes should be your relative changes. So we have a compared, we have a reference. So I believe if we're going up, this one has to be our compared, and this one would have to be our reference. Does that seem right? Okay. I'll give you all like 10 more seconds on this one. Okay, so what are we doing? 81.2 minus 76.4, and we divide that by 76.4. Move that decimal 2 places, and you got a percentage. 6.28%. Should be something in that range. What are you doing? Oh, you went the absolute difference. No, they're asking for a relative difference. So one more step. This again is a percent, so this should be a relative difference, is what it's telling me. In 2015, the median age at first marriage of women was 27.1, which was blank percent less than the median age at first marriage of the US men, 29.2. So this is telling me what direction this thing should go in. And if it's saying less, and that means it's decreasing, it should be going down. And so that should tell you like what sort of number, whether your number is negative or positive. You don't have to put the sign in here because it's accounted for like right here with this word, if that makes sense. So you should definitely be getting a negative number. It should be going down. And that should tell you the reference. Once you subtract them, you know what order they're getting subtracted in. You know which number you have to divide by because it's always the second one in there. All right, a few more seconds. Okay. All right, so it should be 7.19. What are we saying? Yeah. So this is like I was saying. You really should not put the negative in there because it has the word less here. But like I know you know what you're doing. You're on the right step, on the right process. It's just a bit of like the wording and the vocabulary they use in the problem. 7.2, y'all just rounded it. That's good. So some people are getting it. There's a few. A little bit off, but looks like a lot of y'all are getting it and it's just not counting it right. The population bureau. So this is a vocabulary one. So the population of Michigan is 63% greater than the population of Missouri. So Michigan's population is blank percent of Missouri's population. So this is a vocabulary sort of thing, and it goes back to how these two terms relate. So if we're going to go up 63%, what would be the percentage of this thing? So we're going to take one of these and we're going to add 63% of it to get to one of these. How much is a whole thing when we talk about percentages? Because we're taking a whole thing and we're adding 63 more percent. All right, I'm going to give you like 10 seconds now. Okay, so you're taking 100, or one of them is going to be 100% is the whole thing, and you're adding 63 more to get to the other thing. So it's going to be 163% of. So if we're going 63% greater, it's 163% of. And so we talked a little bit about this. It's what, 100 or P plus 100, I think is how we're getting this. And then the other way, what if we go down? It's not P plus 100. So this would be going the other way, I believe. Population of Hawaii is 52% less than the population of Arkansas. So the population of Hawaii is blank percent of the population of Arkansas. I laughed when I see Arkansas because I swear to God, it's Arkansas. If they wanted it pronounced differently, they should have spelled it differently. It's a cruel game to play on students learning their states. Okay. We went 100 plus P in the last one. This one, if we go down, if it's 52% less, if we take one of the populations and we reduce it by 52%, how much of that population is left? If you're at a 30% off sale, how much of the price are you going to end up paying? Right? Same sort of concept. If you can dodge a wrench, you can dodge a ball. Okay, I'm going to give you all like a few more seconds, not too many more, like 5 or something. I got 5 on it. Some participants. What am I reading stuff for? I don't need to read that. This is like I'm like the weatherman. Just read whatever's on my teleprompter. Okay, it looks like most of us are getting this. If we're going 100 and we're subtracting 52% out of it, we're going to get 48%. So these are things that you might have to know. What happens if I have to increase by tax? What happens if I get a sell on an item? So the wholesale price of a toaster is 30% less than the retail price. Therefore, the wholesale price is blank times the retail price. Okay, so if you're taking 30% off of something, I guess I'll go ahead and say it. You're going to pay 70%. That's not what they're asking for. There's one extra little step you have to do. They want the number that you're going to multiply by. So you have to convert that to a decimal. So they want the decimal form of the percentage is what they're asking. And I told you what it was. Hopefully it's quick. I'll give it all till I drink a sip of water. Oh man, are y'all falling asleep? What is 70% as a decimal? That's what this is asking. And with that, I'm not spending more than a few seconds. You should know how to convert percentages to decimals. And if not, that's why I got office hours. Come see me. We'll work through it. But I can't do anything if you're not going to, like, you got to take some initiative in your own education, you know? If you're not getting stuff, you have to come to me. 70% is a percent. If we want the decimal, it is 0.7. 0.70. I hope that counted it right with the 0 in there. It may or may not have counted it right with the 0 in there. It's right. Same difference. The original retail price of a TV is 20% more than its on-sale price. Therefore, the retail price is blank times the on-sale price. So now we're going 20% more. What they're wanting is the number that we're multiplying by. So if we go 20% more, what's the percent of is the first thing that you got to think about. So if we're going up 20%, we have blank percent of, And then you got to convert that percentage to the decimal. All right, so this should be pretty quick. It should be like a 15-second question or something. So we're gonna take 100%, add 20, we should get 120. When we convert what, 120% to a decimal, it should give you 1.2. So 1.00 is 100%. If you want 100% of something, you multiply it by 1.00, you multiply it by 1, you get it back, right? Is what that's saying. I'm doing 80. No, we're going up this time. All right. So some people went down, look like maybe. Yep, okay. All right, so we want to do an absolute change in terms of percentage points. Oh, these are percentages of percentages is what we're doing now. So if we look at this, I'm really sort of particular about your units. So when you answer this question about absolute changes of percentages, you should use the word percentage points, because that is a different thing than saying the word percentage. So somehow in your brain, make sure you know that percentage points is a different thing from percentage. It is not the same sort of metric. And so describe each of these as a follow in two ways as an absolute change in percentage points and relative change as a percentage. So they kind of tell us what we're doing. We're doing absolute change. So we want to find the absolute difference here. The percentage of Republicans in the House of Representatives increased from 40.9 in 2010 to 55.3 in 2016. And then it went down again in 2020, I think. The House, no, that was the Senate, went up definitely. 40.9 to 55.3. We want to talk about the absolute change of those. And the units on the absolute change when we talk about percentage is called percentage points. And so do not put the percent sign. I can say that much. You should say the words percentage points when you talk about these. I've seen some people abbreviate them PP, which is okay, but you should really like stay away from using the sign on when you're talking about points. Sometimes I think they just avoid the word percentage. Sometimes they'll be like, it's up 4 points or something, right? I think this is what they mean. All right, so this should take you 10 seconds. There's one operation, and then you gotta do the one operation. You gotta find the number, and you gotta put the word percentage points. Okay. Kel Dolores. All right, so this is 14.4. We are doing the absolute change, and it should be something like 14.4 with the words percentage points. Ooh, rounded up a little high, I think, maybe, or something. Okay. That is percentage points. The other thing is percentage. So by what percentage is this going up? Not response. There we go. So now this is the one where we want percent. And round it to 2 decimal places. Oh, excuse me. So we know previously we have 14.4 was the previous one. So there's one more step you should be doing to find your relative change. So these sorts of things, I'm hoping they take you like 30 seconds. Okay. We have done enough of these. If you're not getting what the difference is between what absolute change and relative change, then now's definitely the time to sort of ask, sort of get that down. Okay, should be 35.21%. Is that what you're saying? 135. All right, so it looks like maybe just some of it's rounding. Describe each of the following changes in two ways: as an absolute change in terms of percentage points, and as a relative change in terms as a percentage. So this one, we want to do percentage points. And so this is alcohol by high school seniors decreased from 50% in 2000 to 35.3% in 2015. So again, this is kind of a review of the absolute change and the relative change that we just did, but now we have words, vocabulary words that we got to kind of add there. You got to make sure you put these things in the right order. Hint. This one, you got to make sure it's definitely there. But you should make sure you're got the right sign. Make sure you have the word percentage points. And so this should be hopefully a really quick. So new minus old. And new minus old over old. Compared minus reference. Divided by the reference. Cool. All right, so what was it, 14.7? Is that what we're getting with the difference between the two? I believe it was 14.7. That's it. And so it should be a minus 14.7 because it's going down. Kel Dolores. Okay. It is going down 14.7. There you go. What y'all do? Round stuff or try to do the next one? Percentage points. Should say percentage points. I think all of y'all said it, right? It's just it didn't count it because you didn't say percentage points. Okay, that's fine. Make sure you know what the difference is between a percentage point and a percentage. And it's like we're doing percentages of percentages. So that's why you got to be very specific about what you're talking about. All right. Talking about points can be very sort of deceptive too. But it's the same problem, but now we're doing relative change. So we know the solution to the previous one was minus 14.7. We're going to take that. Make sure you put the right sort of units here. Make sure you put the right sign. But this one should be like one extra little step, right? And then we're pretty much there. Oh, wow. Okay, I don't give y'all too much time on this one. Let's go. It should be, where are we at? Yeah, it should be minus 29.4%. Yep. Did I not put the percent sign on there? What did it say? Maybe I didn't. No, that's probably right. Okay. The total after-tax cost of a laptop is $1,278.24. The local tax rate is 7.6%. What is the pre-tax price? Okay, so what they're saying is that this after-tax price is going to be 7.6% more than your pre-tax. So I want to like maybe go over how to think about this, because this one is a little bit backwards maybe from how you might solve it, right? Is that what they're doing? They're doing the after-tax price. Yeah, that's right. And so what we're going to do is we're going to take our pre-tax price. We're going to take one of these. We're going to add 7.6% of one of these. So what this should look like is 176. Did I say that right? 107.6% of this thing should equal to this thing. So we're going to multiply this percentage times, if you want to let this be X or a variable, you can, but it's multiplication by these two things to get to here. And if we're multiplying by 107.6, and we don't want to do multiplying, we want to undo the multiplying. What is the opposite of multiplying? So you're going to take that percentage and you're going to do that to that number. What is tax? 8.25% or something, I think. So usually you do 1.0825. I guess it's here at 7.6. 1.076, I believe is what it is, right? 1.076 times this thing would get you to here. So how do we work that backwards? And then you're going to have to round up a little bit on this. It's not going to be an even dollar amount, but it should be a dollar amount. So your solution should have hopefully a dollar sign in it. And then obviously if it's dollars, you typically round to 2 decimal places. Give this a roll. Try to do something, man. We're gonna go over it in the next slide anyway. Also, your price should be less, right? So sometimes using your context, like, am I getting a lower number than that? If not, then you're probably not doing it the right way. Is it reasonably lower? It's like a little bit lower than this. Okay. Yeah, this is about the response that I've been getting today. I think we'll go and look at how this is done. I try to give you a bit of a hint, but it should be 1187.96, I believe, is what we're getting. Ooh, I don't know if I put a comma in there. Yeah, but it should be 1187.96. So it might have been
I
my.
messed up so bad. I don't know how I did that.
So we got a slide right here. So what we're doing is, this is what I was kind of talking about, right? We're taking one of the pre-tax price. I don't know what the heck it is, but I know it's one of them. It's 100%. I know I'm taking that 7.6% of it. If we look at this thing, we can also combine it. This is kind of like I'm saying with the 8.5. If you ever had to work somewhere and the power went out, you had to do it on the calculator, you probably multiplied everything by 1.0825 or whatever, right? You add up all the items and then you multiply it by 1.0825.
How come the pre-tax is less than the after-tax? Shouldn't it be more?
No, so you're gonna add tax to it to make it go up. This is coming out before tax. Tax is going to add on to your price. And so, yeah, that's something to really, really notice. Like, do we know what number we're referencing, right? Because every time we see a percentage, this percentage references a number. Here, we don't know the number, so we have to do a little bit of like back solving and divide by this number. If we knew the retail price, if we knew the number this was referencing, it would be a little bit easier to solve probably, right? It'd be a little more straightforward, I would say. But if we want to go this direction, we're multiplying in order to get this number by itself, or however you want to think about it, you're doing the opposite, right? You got to divide by this. So this is 107.6% of this thing. So if it's of this thing, it's divided by this thing. So it's important to note like which one you're starting with. If you don't have your reference value, right, the reference value of this thing, it probably means you're going to have to back solve it somehow like this. And so this is going up 7.6%. We can also go the other way. We can have cells, right, and go down. Questions about this? Is it making sense, hopefully? Well, now that I put the numbers up there. It should be round this to 2 decimal places, 1187.96. Okay, cool. Question view. Here we go. Shifting reference value. State whether the following statements are true or false and explain why. If the statement is false, state the true change. What does that say? Oh, state the true. Okay, yeah. Basically, just kind of explain if the national unemployment rate decreased at an annual rate of 2% per year for 3 consecutive years, then the rate decreased by 6% over the 3-year period. Is that true? Is that false? Why is it true or false? Is it going to do that? True, why? I got to know why or why not. Why are you thinking what you're thinking? If you're saying true, you're probably thinking it's going down by 2% each year for a total of 6%, right? 2% each year for 3 years. 2 times 3 is getting the 6%. Is that true? And this is a big hint, shifting reference value. Oh man. Did anybody watch the video?
Sorry, I'm typing. I'm like trying to focus.
No, you're
I'm a slow typer. That's why I'm like, okay, how? I'm bad at typing and I'm bad at spelling. So I'm like, okay, wait, how exactly do you do this again?
Okay. Yeah, I think some people are maybe hitting out. It seems this is one of those things that it seems like it should be true, right? Maybe. But this goes back at like a percentage is not a like raw number in itself. So you can really sort of deceive people. I talked about that in like the lecture notes. But you can really sort of deceive people by talking about a percent, because if I'm talking about 1% of this class, I'm talking about maybe like one per person. I'm talking like 1% of the US population. I'm talking about millions of people probably, right? Was it 7 billion? Yeah. So it really depends on what you're referencing. And so you got to be really careful on what you're referencing here. So this one should be false. And I think I have an explanation. And the next slide. If the national employment rate decreases by an annual rate of 2%. So this is sort of something we can sort of like work through. I can't even think anymore. Inductively, right? We can get some sort of inductive examples. We can pick out examples. So if you want to pick a number, any number, pick any number out. The 100's a good one, right? That's a good one to start out with. Say we have 100. Our rate is 100. 100 what? I don't know. People per 1,000 people are unemployed or something. Let's just say our rate starts out at 100. Because if this works, or if this is true, right, it should be true for any number I pick. That's the sort of thing about a math statement. We want something that's true of everything. So if it doesn't work for one thing, one counterexample, kind of just proves it. So if I can get a counterexample, then that's kind of my goal, right? So if I start out with 100, I want to see if it goes down by 6%. So I should end up at 94 if I'm going down 6%. So this is the first year. I have 100. It's down by 2% of 100, where we're going to reduce it by 2. We're going to be at 98. And so this year, it's looking good. This year, this is the one that's going to give you trouble, right? So in the second year, you're going to go down by 2%, but you're not going down by 2% of the 100. You're shifting your reference. Now your reference is what you started with. So what you ended here is what you're starting with here. So now we're referencing 98, which is like 1.96. It's not quite 2 points, right? And we're going to be at 96.04. You might figure the next year it's going to be even smaller, because now we're starting with this as our reference. So each year you're referencing the previous number, not the first number, which was 100. So this is your reference is changing, it's shifting. And so you'll be at 94.112, which is not quite 6 whole points down, right? It's a little fraction over, and it makes a difference in this case. Ooh. Questions about this? So this is one of those things you have to be careful of what you are referencing. If we're going down 2% each year, our reference actually changes each year. It's not going to be quite the same. That's 2% of the original thing, or 6%, or whatever they said. It's not going to add up like that. So is it possible to determine whether the following claims are true? Explain your answer. And I bought a surfboard online and saved 125%. Okay, this should take 3 seconds. Is this true? Are you saving 125% on something? If you do, if you know where to get that deal, let me know, right? Yeah, it would be giving you money back. You cannot do over 100% is what this problem is trying to get at. You cannot have a sell over 100%. That was something they talked about in the notes. Ooh, so I hope when you hear 125% sell, you just rush there because it means they're giving you objects and they're giving you money back, right? Just go for it. And it's not going to happen. Is it possible to determine whether the following claims could be true? Explain your answer. Average hotel room rates have increased 100% in the last 20 years. Is that possible? Can things go up 100%? Yeah, it's just price doubling is all it is. If we go up 100%, yeah. So we start out with what, 50 is going to go to 100 something. Start out with a number, you basically double it, you're going up 100%. Yeah, 100% increases are okay. You can go up 200, 500, you can go up 100, you can go up 1,000%, right? There's no maximum on the percentage you can go up. There's a maximum on the percentage you can cut from 100%. We can't go into the negative percentages, right? This is what it's basically saying. Okay. So there's no roof, but there is a min when we start. Wait, there's no roof on the roof, but there's no whatever. I think I'm just missing things more confusing now. Okay. Average percentages. Suppose you have an 80% average in a class going into the final exam. You receive a 90% grade on the final exam. In general, does it follow that your average for the entire course is 85? So in this class, this is definitely not true because we have a weighted grade. But what I think they're asking is like everything is equally weighted, I think is what they're probably assuming in this problem. Like if all your assignments were equally weighted, would this be true? If we get 80% average in our class going into the exam and we receive a 90 on the final, is that going to mean that we're going to get an 85? Yeah. Yeah, and this is one of those ones, 14. Are people answering it and I'm not seeing them? I think it's lagging. Let's see. I said 14 new responses. Maybe it was like lagging from the previous problem. And this brings up a really good point. What if they have this thing? No, I don't want to go through that. I'll talk about that in a second after I talk about the correct way to do it. There is one way that this is going to be true. Let's just say it that way. And you're kind of hinting at it and you're correct. Yeah, it's not going to be. And a little bit, did I give I can't remember if I did a slide that has an explanation. But if we have 80% of the problems correct here and we have 90% of the problems correct here is what this is saying. Explain. Does this have an explanation? Oh, I think this is one I forgot to explain on. So let me annotate it a little bit and I'll just do some annotation. But we have 80%. Let me type that right. And I don't know how many problems we had, but going into the class, what we have, let's just say we have 100 problems on stuff leading up into there. Every assignment that we did, you did 100 problems. And then the other thing you did, maybe like there's 10 problems on the final or something. So if we average these two things together, I think we're going to get what? Something like 890. Did I do that right? 89, sorry. And so what percentage of the things did you actually get correct? You got 89 out of the 110 correct. And so 89 out of 110 is what? 80.9. So does it follow when you take these two things, that you're going to get 85%. No, we got 80.9%. Giving an example with 100 problems on the first one and 10 problems on the first one, on the second one. So this is coming back to the percentages reference something. And in general, we don't add percentages, right? We don't average percentages. So we're doing 80 and 90 and averaging them for this 85. That's not something you want to do. They work out in one case, and I think someone kind of hinted at it, if they have exactly the same problems. That's the only way it works out. Say there's 10 problems here and 10 problems here, it would coincidentally work out. But that's like, it's just like, that's coincidental. You don't want to, definitely don't rely on something that's a coincidence, right? Don't bank on something that's a coincidence. That's kind of foolish. But here we go. Getting close, I think. 40% of students at an orientation are women, and 20% of the women are engineering students. Therefore, 40 by 20% is 8% of the students at the orientation are female. Is this true? And how are you proving it to yourself is the other question. So that might be a little tricky. Are there new responses and it's just not loading them? That's what I'm afraid of.
I think we're all just typing in like long responses.
Yeah.
A while to figure out what exactly I need to do.
It's like thinking time plus writing time equals you're waiting a while.
Yeah.
Except for that moment right there, that single word.
This one is a little bit tricky. I'm not trying to rush y'all. I just don't want to be ignoring y'all or having that dead space where we're all waiting on each other, right? It's just like kind of silly. We're wasting time.
Doesn't help that you wrote out the word 40 and then later used 20, the number.
40%. I copied and pasted this, I think. I think it's from the book. I could be wrong.
Why would they switch it like that?
Because this is butted up
It's like
against another number.
I don't need the word. I just need the number.
No, I think they did it because this is butted up against the problem number. So if they said 83.40 or something percent, like that would look really crazy, right? It would look like 83.4% or something. So try it. Like, why are y'all saying false? Have you tried it with the number? Try it with 100. Does it work? If I take 40% of 100 and then I take 20% of that, do I get 8? If I multiply by what, 0.4, and I multiply by 0.2, is that the same thing as multiplying by 0.08? This one, true, correct answer is weird. Okay, this one is maybe a little bit weird, but it is absolutely true. It should be true. You should be getting it. And if you pick a number and you do it like that, you've proven it to yourself, but like kind of only, what do I say? But you haven't really proven it, right? I guess until you actually like do sort of something more formal, I guess. But like this is sort of like I was saying, I think I picked the number 200. So if I pick the number 200, and I did this so I could have the steps laid out. 40% of 200 is 80, and then I do 20% of 80 is going to give me 16. So 16 out of 200, I can't speak. 16 out of 200 is going to be the 8% that we were looking for. So that seems to be correct. But this is like I was saying, this is only like kind of showing me an inductive sort of proof, right? It's not actually proving it beyond a shadow of a doubt like we like to do in math. So like, think about this thing. What did you do to this number? You start with a number. I started with 200, but I really could have started with anything. And I multiply it by 0.4. I multiply it by 0.2. And so there's this property of associativity, I believe. It doesn't matter like sort of where we put the parentheses when we multiply things. We can multiply these two things first. And if you do that, you get the 0.08, right? And so this is where they're getting the 0.08. So if we do 40% of 20%, we can do 8%. We can multiply those percentages. Questions about that? I know I just skipped past that page after I asked these questions, but I can go back if you want to look at it. But that last part sort of is a little bit stronger proof, you know, than just taking numbers and plugging it in. You notice the pattern and then you want to talk about the pattern, sort of. That's what we do in math, right?
This question, is it 20% of the cars that have Bluetooth?
No,
Okay.
of the total cars. This is getting at something that is going to come up again and again sort of later, but they're kind of throwing it out here. They're here. 50% of the cars in the rental pool have Bluetooth, and 20% of the cars in the rental pool have GPS. Therefore, is it true that 70% of the cars have Bluetooth or GPS? And maybe you could try to think of an example. But this is really going back to those, like, sort of, I don't want to say too much, those Venn diagrams, right? I'll give you all a few seconds on this one, but I will definitely talk more about it. I guess you all got like a 50-50 shot on this, right? It's like, either yeah, no, I don't know. Well, yeah, or no. True or false? I think I don't know, actually. Oh, come on, have some confidence. Man, like, man, oh man, I'm telling y'all, like, and I'm not trying to sound like a jerk, but like think about like what your job is to do as a sort of student, right? Like, and what your job is to do on a test. Like your test, like the test is there to guarantee you have learned the information. Like, it's like when people write "I don't know" on my test, like that doesn't make your professor necessarily want to give you points for those questions, right? It's better to like sort of feign confidence sometimes. I don't know. And I realize it's like you're probably just frustrated and you're just writing that on there. I'm not trying to say I take it personally. I'm just trying to say, like, I don't think it's a good strategy is what I'm trying to tell you. Okay. You should have had enough time to give you your sort of input. But this, I have an example, and I want to look at my example. So this is my example, 50%. I believe there's 100 cars here, right? 50% or 50 of them have Bluetooth, which is this 40 and this 10, and 20% have GPS. I got 100 cars here. Bluetooth is that 40 and that 10. Like I was saying, gives me 50%. GPS is 20%. If I talk about cars that have Bluetooth or GPS, how many am I getting? 60? Why am I not getting 70? And people kind of hinted at it. It has to do with this guy right here, right? And so when I'm adding these, when I go 50 plus 20, I just added this thing twice. So you added your intersection twice because you added it when you did Bluetooth and you accounted for it when you did GPS. So you basically accounted for this area twice. So if you accounted for it twice, you could also subtract by it. Is another way that they do it. If you subtract by 10, you get the 60. That's one way to get it. But there is this overlap of 10 that is making this one basically 10 less than this one, right? So it doesn't really follow, and it doesn't really follow because they have overlap. There are cars that could have both Bluetooth and GPS. And if you have overlap, which is a possibility here, it's not just going to be those things added. So we really got to account for overlap when we start talking about occurrences. And we will talk more about this when we get into the probability and statistics section, like at the end of the, more towards the end of the semester. I think we got accounting coming up pretty soon. Okay, for the 445-50 men in the arena compromised 85% of the people. How many people were in the arena? Okay, so this is one. You might want to be careful on this one. 85% of the people in the arena. So you take 85% of the people in the arena, and it should give you this number. So I'm trying to give you a hint, but should be a bit of back solving, I think. And you're gonna have to round to the nearest whole person. This one is a whole number, just because of the context of the problem. We're not trying to split and quarter people. Drawn and quartered. So 85% of this thing is equal to this thing. So of means we're multiplying. If we're working backwards, we're doing the thing that's not multiplication. Where are we at on this thing? Oh, we're almost there. Come on. And we get the of. It's not the greater than, so it is like it is right there. We're using this number. And then the other thing is context, right? If these are the men, all the people in the arena is what we're figuring out. All the people should be probably a larger number. So you should probably be getting something a little bit larger. Okay. No, I think I might have broke this down on the next slide. Okay. So what I'm seeing in my head, this is like further things. I'm taking 85% of the people in the arena. I don't know what the heck that thing is, but I should be getting that other thing over there. That's sort of what I'm seeing in my head. Now, how do I solve for how many people are in the arena? Okay, I think it's time to move on to this one. Do you want to proceed? Yes. So you should be dividing the thing, right? So you take 45, 50 men. We're dividing it by the 0.85 to get the number of people in the arena. What did y'all get? 53, 53. I think you put the numbers in the wrong order. 53.53. I think you did not convert this to a decimal. I think is what happened there. 53.
Yeah, I did. I completely forgot the last thing. The minute I plugged it in and hit submit, I was instantly like, "Oh, crapples! I did something wrong. I can't fix it."
And, I mean, this is I don't like this is the time for y'all to figure this stuff out, right? I'm not expecting y'all to get this stuff right in this stuff. 53, 52 didn't round it up. I think you just missed maybe the way that you put those numbers in there and flurbed it. It looks like most of y'all.
What was the correct answer?
53, 53.
Okay.
And we're taking 45, 50. We're dividing it by the 0.95. Oh, there it is. There's a whole page of it. But that's what I was talking about. Oh, it shouldn't say men on this last one. That should definitely say people. There were 45, 50 men. There were 53 people. Used the wrong word. But there it is. I think this is the last one or second to last. We're almost there. I know it's 4:20 already. 2016, 84% of households with television subscribed to cable, an increase of 7.8% over 2000. What is the percentage of households with televisions subscribed to cable in 2000? Woo! They are giving me a whole bunch of percentages. This is the percentage in 2016. We know that this is an increase of 7.8% from this thing. Whatever the heck this thing is. So it's an increase of 7.8%. So if it's an increase of 7.8%, we've done this enough. Let's go ahead and do it. 1.078 is the number that I'm multiplying by. It's 7.8% more. It is 107.8% of. 107.8% of what? I don't know. It's the 2000 percentage. So this one is percentages of percentages. And this is going to give us the 84% that we see over there. So the solution that we should get should be a percentage. And I kind of have this set up. If you don't know how to solve this from the way that I have it set up right here, definitely come by and ask me about what the heck I'm doing. That should give me a percentage to 2 decimal places. So it's a bit weird because they're doing percentages of percentages. But I'll talk about it in just a second after we get this thing down, how I would describe it. Oh man, where y'all at? Did I lose some people? Looks like I lost some people. Should be dividing those two numbers, right? Is what we're doing. If we divide those two numbers, what was it, like 77 point something? What did I say? 77.92, I think. I think it's going the other way. People are cutting cables nowadays. They're not. What are y'all saying? 77.92, 90, should be 77.92. And so what does that mean? We're going 77.92. And we're going to where? 84%? And so there are two different ways we describe this, right? This would be what? A 7.8 more than? Sorry, more than. And then the other way we describe it is would be what 107.8% of. So 84 is 178% of 77.92 is what we're saying. So this, I'm just throwing this up here because I know this is percentages of percentages, and I know that's like kind of confusing. Like, well, what percent are we talking about and what context? So these are the two kind of raw number percentages, I guess is what you could say, right? And these are the percent changes. And how would we talk about them? Is that making a little more sense maybe? I know there's a lot of percents on there. It's like, what the heck are they doing? Okay, that's that one. Wow. With 2.4 million digital subscribers, Game Informer magazine ranked first, has 1150% more digital subscribers than Geographic. How many digital subscribers does National Geographic have? So if this is 1150% more than, we're going to start out with one of the National Geographics. We're going to increase it by 1150%. What percentage are we doing? That's the first thing I would really do here. So that there's a little bit of a vocabulary thing. And I wouldn't do 1150% more than. I'd go ahead and do this as what? 1250% of. If we want to do that, I believe moving it 2 decimal places at 12.5 is probably the number we should use. So how are we going to get how many subscribers this guy has? And you can put it as, you can put it in millions or you can put it as a whole number. I think is the two different formats for this one. Is it, if I convert it, yeah. Okay. So I think I did 2 decimal places if you say the word million. And I think I just did a whole number if you convert it without the word million. So I think what I'm saying is this one is a small, well, let me get rid of my annotations. This one, National Geographic, would be the smaller one. So how do I get from the smaller one with the number 12.5 and get to this one? And how do I get from here to here? I got to do the opposite to get from here to here. Do people still buy gaming magazines? I feel like all that stuff is just online now. It used to be like that was the only way, man. If you wanted to know like all the little Easter eggs and stuff, and be the cool kid, you had to get Nintendo Power. I never got Nintendo Power. That was never cool. So where are we at, man? We got 2 more problems. Are y'all answering? This is not responding.
I'm just a little confused about this one.
I am
Okay.
confident I got this wrong. I'm pretty sure I did something wrong.
Okay, this Game Informer has 2.4 million. That is 1150 more. I don't want to say that. That's 1250% of National Geographic. So if I want to know how to get from National Geographic to Game Informer, I'm going to have to take the National Geographic population over here. I'm going to have to multiply it by this to get to this, is what this is telling me. So if I'm going multiplication this way, multiply this by this to get to this, going the other way, the operation is what? 2.4. I'm going to do something with this 12.5, and it's going to get me here to National Geographic. The opposites, that's not multiplication. The inverse of multiplication is what? Division. So if you take 2.4 and divide it by 12.5, I think that's what we're doing here. Does that make sense?
Yes.
This is going up 1150%, 1250 of. So we gotta go back and add one of these to it, basically, right? But it's easier to find out with the of vocabulary than it is the more than. Because we know of just means multiplying. It's sort of easier to throw it into a formula then. So if we divide them, I think we get what, 0.192? And if you said 0.19 million, I think you got it right. 0.192 million, it might have counted it wrong. I don't remember. The other thing is it's like 192,000. So if you wrote it out, did anybody write it out that way? 192,000 right there. Here we go. 192,000 is also another way to write it out. That's correct as well, right? That's the same thing. We got one more slide. One more. Unemployment rate has risen more than a percentage point to 8.5 in February from 7.1. What is the relative change in the unemployment rate expressed as a percentage? So the last one, just find me the relative change of this one, and we're done with the homework. I don't feel like this one is really throwing any screwballs or anything. It is percentages of percentages. So I guess that's a little weird. And it's risen, so that should tell you probably, hopefully, what direction you're subtracting these things in. I'm gonna say 19. Oh, man, I didn't finish typing my answer. Let's see if my quarantine cut's still straight. All right. So find the relative change between this and this is what we're doing. And it should be positive, so that should tell you this one's going first, this one's going second. So what are we doing? 8.5, we're going to subtract the 7.1, then what? Divide by the 7.1, which is the reference, or the old guy. Ooh, 0.84, where are you? 0.84. I don't see 0.84. Yeah, I think we're hitting around it, right? It should be 19.7 to 19.7, somewhere around there. wonder if Kel Dolores knows how to sing De Colores. Do you know that song? I remember that from like Spanish class, De Colores. It's like a Spanish song. It was on the little game that we used to play. Anyway, that's it. That is all I got for you today. If you got questions, I will be around. I got office hours right after this.
Thank you.
And any questions, I am here.
Bye.
Take care. Watch the next video before class, please. Stop share.